VPC, right? You are essentially reserving a pool of private IP address space. And this pool of private IP address space is being consumed by the resources that you host or that you provision in that particular VPC. Okay? So this is really just a pool of private IP address space. Now, with that pool of private IP address space, you are able to logically segment or partition your VPC into subnets. So this is a logical partitioning of that private IP address space. And moreover, subnets can also be a logical grouping of identical resources or similar resources, because this is where you'll be launching your resources inside a subnet within a VPC. In addition to that, subnets can also be used to define the accessibility of these resources, because a subnet can be characterized to either be a private or a public subnet. A private subnet is characterized to exposing, or rather not exposing your resources over the internet. Therefore, private subnet resources won't have internet connectivity, and they also won't be accessible from the internet, which makes them secure. And this is the subnet where you would possibly launch your application servers or database servers, because typically these are the resources that you do not want to provide direct access from the internet. On the other hand, a subnet can be created to be a public subnet. And a public subnet is simply the opposite of the private subnet, whereby in a public subnet, the resources are exposed over the internet. Therefore, they can be accessible from the internet, and they also have internet connectivity. And a public subnet is perfect for things like your network address translation, your load balancers, your firewalls, your proxy servers, and so on. Now, VPC is a regional service, which means that it spans the whole region, making all of the availability zones available for use. A subnet within the VPC, on the other hand, is spanning a single availability zone. It spans one availability zone, but an availability zone can have multiple subnets inside. Okay? Now, since VPC is providing you with a network environment, it is inevitable, especially in an enterprise organization, that you would want to extend your VPC to a hybrid connection with a remote network environment. And your VPC does have multiple options of creating that hybrid connection. You have the option of creating a VPN connection. And VPN is where you have an IPsec tunnel where the traffic is going over a secure and encrypted connection over the public internet. So VPN is a viable option. But since the traffic is going over the public internet, although it is secure and encrypted, it still might incur some security or some performance concern. So as an alternative, you have the AWS Direct Connect. And AWS Direct Connect is our DLL, where it provides you with a dedicated physical fiber line that connects your data centers and AWS. Now, in order for you to have a Direct Connect connection, you need to be working with our Direct Connect partner, which here in the Philippines would be the ISP. You communicate with them. You ask them for a specific band. Go to your data center. They plug in that DLL private connection so that you have a dedicated private line that connects your AWS, that connects your data centers with AWS. And with that, it is much more secure and gives you a consistent network performance because the bandwidth is allocated for your use only. And finally, you can create a VPN cloud hub where a single VPC can be connected to multiple remote network environments via multiple VPN connections. Okay, so here is a sample configuration of our VPC. Now we have our VPC that spans the whole region. and give us a private IP address space, a pool of private IP address. Now, from that pool, we are able to segment or partition our VPC into subnets. And remember, a single subnet only spans one availability zone, but an availability zone can have multiple subnets inside. As mentioned, subnets can also define the accessibility of resources, because subnets can either be public or private subnets. Now, for you to create a public subnet, you would first need to have an internet gateway component attached to your VPC. This internet gateway acts as a two-way proxy that connects or that enables communication between the VPC and the internet. And once you have that internet gateway in place, you will then need to associate that with your subnet, who you would want to be a public subnet. In contrast, a private subnet does not expose your resources over the internet. Therefore, you don't want to associate the internet gateway with the subnet that you want to configure to be a private subnet. But in some cases, resources in the private subnet, you would need to connect it over the internet. You would need to provide your private subnet resources internet connectivity in a secure manner. For example, your application servers, your application code would need to install patches, libraries that are available over the internet. For your database would also need to fetch these patches and updates over the internet. So you would still need to provide your private subnet resources with internet connectivity, but in a secure manner. And how to do so is with a NAT gateway, or a network address translation. Essentially, this would act as a one-way proxy that will allow internet connectivity to be initiated from the private subnet going out the internet, but not vice versa. And the keyword here is that the internet connectivity must be initiated from the private subnet. And finally, you can configure a subnet to be accessible via the hybrid connection. And in order for you to do that, you need to have a virtual private gateway. Once you have that, you can then establish a hybrid connectivity either via VPN or direct connect. And again, you would need to associate that virtual private gateway to the subnet that you only want to be accessible via the hybrid connectivity. Okay, so that is a sample VPC configuration. And finally, imperative to discussions on networking, security is key. And in our VPCs, we do have multiple layers of defense in the form of security groups and network ACLs. So security groups are layer 4 firewalls. Or essentially, both of these are layer 4 firewalls. And being layer 4 firewalls means that we are able to restrict traffic based on port, protocol, and IP range. Specifically for security groups, these are your firewalls at the instance or resource level. Okay? Now with security groups, as you've seen, we are only able to define whitelisting rules. Okay, which means we simply open the port that we want to allow traffic to enter. Furthermore, these are stateful firewalls, which means that if you allow traffic to go in one direction, the response will be automatically be allowed to go the opposite direction. Essentially, it bypasses the rules that you've defined in the opposite direction, and it also remembers the state of that connectivity or communication, whereby if you allow traffic in one direction, it automatically allows the response to go the opposite direction. Right? Now, on the other hand, you also have the network ACLs. Now, the network ACLs, in contrast to security groups, these are applied at the subnet level. Now, with network ACLs, we're able to define both whitelisting and blacklisting rules. Furthermore, network ACLs are stateless firewalls, which means that if you allow traffic to go in one direction, you would still need to explicitly allow the traffic and the response to go the opposite direction. Okay, so these are the firewalls in our VPC. Security groups, stateful firewall at the instance level, whereas network ACLs, stateless firewall at the subnet level. Okay, and as an added layer of defense for our EC2 specifically, we have the key pairs. And these key pairs follow a public key cryptography to secure our logins onto our EC2 instances. Okay? So that is it about the basics of VPCs. Essentially, VPC provides us with a private, isolated network space in the AWS cloud. And we've also discussed different components of our VPCs, which includes the subnets and the gateways that we can attach. Furthermore, we've also looked at the different options that we have in establishing that hybrid connectivity, usually either via VPN or direct connect. Furthermore, we've also looked into the different layers of defense in our VPC with security groups and network ACLs. Security groups being the instance level firewall that is stateful, network ACLs being the subnet level firewall that is stateless. Right? So before we transition on to our next topic covering storage services, are there any questions with regards to network? Any questions, or is everything good so far? Can I show you a demo? Absolutely. But then again, in the interest of time, we might need to extend our time. But no issues. I can show you a demo. Now, when creating our VPCs, we need to be redirected to the VPC dashboard. And so we go to the VPC console. Right? And as mentioned, our VPCs do have a lot of components. We have the VPCs itself. We can create subnets in our VPCs. We can define the routing. We can add the gateways, define the firewalls, and so on. You can create each component one by one, or you could launch VPCs via the VPC wizard. So this is giving you an option to streamline the process of making VPC creation much more simpler. It provides you with templates that will make creating VPCs much more simpler. The templates would include a VPC with a single public subnet, a VPC with public and private subnets, a VPC with public and private subnets and hardware VPN access, and VPC with a private subnet with VPN access. Okay? So for this demo, I'll be wanting to create a VPC with a public and private subnet. So as mentioned, you have complete control over the IP addressing of your VPC. Thus, this will affect the size of your VPC. But for the simplicity of this demo, I will just remain it as the default IP address. I also have the option of having an IPv6 CIDR block. But again, for this demo, I will not be leveraging on that feature. And so I can specify a VPC name. And so let me name this as my demo ABS CBN VPC. And in this VPC, I can define subnets that is characterized to either be a public or a private subnet. And like your VPC, you also need to define the IP range of your subnets. And remember, this is only a subset of your VPC. So this is only a portion of your VPC. Okay? And subnets, as mentioned, only spans a single availability zone. And so we need to define that. But an availability zone can have multiple subnets inside it, which in this case, both of our subnets will be created in AZ8. And for us to be able to provide internet connectivity to our private subnet resources, we would need to create a NAT gateway. And so let me just create a static IP for my NAT gateway. All right, let me just allocate a static IP. Very simple. And I can use that as the static IP address of my NAT gate. Right? So very simple way to configure your VPC. And with that, let me do it again. Hold on. This should be easy A, easy A. There we go. Let me just switch over to a different region. Because I think I'm hitting the soft limits of the maximum amount of VPCs that I can create in a region. Let me just change that. SDN. This would be AZA as well. And let me allocate an elastic IP for my NAT gateway. And there we go. We should be good to go. Very streamlined way of creating your VPC, providing with templates. But then again, you are able to create each component one by one. But that will be much more complex. This is a good starting point, and then you can build on top. Okay. So we do have a question from Gilbert. What is the equivalent of an Azure App Services in AWS? Unfortunately, I am unable to speak on behalf of other cloud platforms, as personally, I do not have experience on those, and we do have a competitive, disclosure agreement. So, unfortunately, I won't be able to speak on behalf of other cloud platforms. So I do hope that you do understand. But there are a lot of things, a lot of sources, articles that you can read upon that is available in the internet. Simple Google search will allow you to see the similarities between AWS and other cloud platforms. But I hope you do understand that I'm not able to speak on behalf of other cloud platforms, especially in this training. Okay. So let us wait for a few minutes for our VPCs to be created. And so while waiting, if there are any more questions with regards to VPCs, let me know in the chat. All right. And now we have successfully created our VPC and all of the things related to VPC. We have a VPC. We have subnets in that VPC. So we just refresh. Hey, we have the VPC. We have the subnets in that VPC, which is either a public or a private VPC. Okay, a public and a private VPC, both are sitting in AZA. We have the components for the internet gateway, as well as the NAT gateway for this VPC. And we have also associated these components to the corresponding subnets. Whereas for a public subnet, that is associated with the internet gateway, and the private subnet that is associated with the NAT gateway. And we do that association through the route tables, which defines a set rules of how traffic should flow in and out of our subnets. Now do note that the VPC wizard only enabled us to create subnets in one availability zone, in AZA essentially, right? And so if we want to have resiliency and high availability in place, then we would need to be creating additional subnets in different availability zones, in AZB potentially. But essentially, with this configuration, we still do not have high availability because our subnets is just sitting in one availability zone. So we simply need to recreate the set of subnets, the same set of subnets in a different availability zone. But I will not be showing that in this demo because of complexity. So this will do for now. And with this network environment, we should be able to launch resources in that network environment. So for example, if we're looking to launch EC2 instances, specify the same details, and for the options of network, we can now launch our instance in the VPC that we created, as well choosing between the public and the private sub. Okay, so that is it for my demo on VPC. Very easy to start, especially if you're using the VPC wizard. So hopefully this demo reinforced your understanding on VPC. Essentially, it provides you with a network environment where you'll be able to provision your resources. Okay, hopefully everything is clear on that. And so if everything is good with networking on AWS, then we shall move on to storage services on the AWS cloud, specifically diving deep into Amazon S3 and Amazon EBS. Now, first of all, our instances, remember these are just virtual servers. And like any servers, we need to attach this with mountable block storage, or in other words, disk drives. And in the cloud, you have two options for disk drives that you can mount on your EC2 instance. One of which would be the Amazon EC2 Instance Storage. The instance storage is equivalent to a direct attached storage. This is physically attached to your EC2 instance. Excuse me. All right. So instance storage. This is physically attached to your EC2 instance, equivalent to a direct attached storage. And because it's physically attached to your EC2 instances, they do provide you with the fastest read and write IOPS performances that exceeds 300,000 IOPS performance. But the caveat here is that since it's physically attached to your EC2 instance, its life cycle is highly dependent on the state of your instance. Essentially, when your instance has been stopped or terminated, all of the data in the instance storage will be lost as well. Which is why this is considered to be an ephemeral or temporary storage that doesn't provide you with any persistence. So you want to use the instance storage like a volatile memory. It is for data that requires really fast read and write performances, but persistence isn't really a requirement. So you could use this like a cache, a buffer, or a scratch disk. For the most part, you would want your disk drives to give you persistence. Because imagine if this was the only option that you have, then you would need to reinstall the operating systems, applications, runtime environment over and over and over again if your instance has been stopped, because everything will be deleted on that instance. So as an alternative disk drive that does provide you with persistence, you'll be looking at Amazon EBS or Elastic Block Store. Amazon EBS is equivalent to a storage area network, a disk drive that is attached over the network. Specifically, this is equivalent to an iSCSI block device, or you can think of this as the actual disk drives that we use with our computers. So this is providing you with that persistent block storage, offering you with consistent low latency performance. Now, it does have built-in durability, whereby Amazon EBS is an AZ scope service, and the data stored in EBS will be automatically replicated across multiple servers within the availability zone. And you're also able to create snapshots, and these snapshots serve as backups that captures the point in time state of your EBS volumes, allowing you to use these to recreate or restore your EBS volumes. So Amazon EBS is recommended when your data must be accessible quickly and requires that long-term persistence. For security purposes, you can encrypt the data at rest on your EBS volumes. And you're also able to create point in time snapshots, which you can use to restore or recreate your EBS volume. And since EBS volumes are elastic in nature, you do have the ability to dynamically change its size, performance, and even the type of the EBS volume while you're actually using it. And speaking of the type of volumes, we do have four variations under two: the SSD and the HDD family. Like common knowledge, SSD is way faster than HDD, but it is relatively more expensive. Okay, and that common knowledge also applies in the AWS cloud.
Hindi ko maintindihan.
So under the SSD family, you have the general purpose SSD, which is giving you a good price to performance ratio, which is great for a wide variety of workloads. Now, the limitation of general purpose
Yung
SSD
kanina
is
kasi
that it can
maroon
only
lang yung
perform
price.
up to 16,000
Ito,
IOPS performance.
Technical.
Now,
Nakakapita.
if your workload requirements must exceed this limitation
Na-record ko na rin.
of going beyond 16,000 IOPS performances, then do consider using Provision IOPS SSD. With Provision IOPS SSD, this is designed to be the highest performing EBS variation that is suitable for your mission critical applications, for example, your databases. And Provision IOPS SSD can give you a consistent performance of 64,000 IOPS and sometimes even exceeding that. Okay? Now, do note that it is only the SSD volumes that you could use as a boot drive. Essentially, these are the only ones that you could use to install your operating systems. Okay? Now, on the other hand, you have the HDD family. And under the HDD family, you will have the throughput optimized HDD. Now, throughput optimized HDD, as the name suggests, gives you high throughput performance for streaming workloads, log processing workloads, and provides you with megabytes per second performances that reaches up to 500 megabytes per second. And finally, you have the cold HDD. Now, the cold HDD is the most cost-effective EBS variation. And it being the most cost-effective also provides you with the slowest performance. So cold HDD is designed for your cold data that you infrequently access, and performance isn't really a necessity. Now, do note that for any EBS variation, you can create EBS volumes up to 16 terabytes in size. Okay? And so with that, you have the option of creating EBS volumes, because in our data centers, we do have a lot of unused EBS, or rather unused space. And so you can create your EBS volumes, sometimes specifying the EBS volume size. And in some cases, you can define both the size and the performance of your EBS volume. But for the most part, it only requires you to define the size, and it will give you a matching IOPS performance depending on the size of your volume. Okay? Once you have created your volume, do note that you will start incurring charges for that volume, even though you are not using them nor have attached it to any EC2 instance. But with that volume, you can attach it to a corresponding EC2 instance. It follows a one-to-one relationship for the most part, where an EBS volume can only be attached to one EC2 instance at a time. But your EC2 instance can be attached with multiple volumes at the same time. It's essentially like your disk drive to computer relationship. A disk drive can only be attached to one computer, but a computer can have multiple disk drives attached to it. And do note that since EBS volumes are AZ bounded services, you can only attach these EBS volumes to EC2 instances in the same availability zone. Okay? Once you have attached it to the corresponding EC2 instance, you then will be able to format it and mount the volume so that you could use it. And you can create snapshots point-in-time snapshots that will allow you to back up your EBS volumes, and these snapshots will be stored in S3 in the back end. You also have the option of detaching your volume and reattaching it to another EC2 instance. But ultimately, you'll be able to delete your EBS volumes so that you completely terminate or decommission your EBS volumes. So EBS can be used the same way of how you use your disk drives. These will be used to install your operating systems and essentially any applications that you want to be running on your EC2 instances. Okay? In terms of pricing, your EBS volumes will be priced based on the storage size as well as the IOPS performance. Furthermore, the EBS volume type will also dictate the pricing of your EBS volume. Okay? Now, do remember that EBS volumes are bounded by AZ, but it does provide you with built-in durability where the data that you store in the EBS volume will be automatically replicated across multiple servers within the availability zone. So those are the two options that you have for disk drives. You have the EBS and instant storage. Amazon EBS is equivalent to your disk drive that gives you a persistent and consistent performance. On the other hand, you have the Amazon EC2 instant storage, which should be treated like a volatile memory. And this one gives you really fast read and write performances. But then again, this is merely an ephemeral or temporary storage.
Disk drive.
Okay? So to quickly show you a demo on Amazon EBS, how do you actually create Amazon EBS volumes? Well, you can create EBS volumes as part of the EC2 creation process. You know, when you launch your instance,
Nangingiting ko pa to?
you do have the option of adding storage, and the storage that you are adding would be EBS volumes. Okay? You can choose among the different types. Right? And for the most part, as mentioned, you only need to specify the size, and we will give you a proportional amount of IOPS performance. So obviously, as the size increases, the performance also increases. But specifically for Provision IOPS SSD, it does entail you to define both the size as well as the IOPS performance.
Akala ko nga, sabi ko kinakabahan ako bago magpasok eh. So lagi ako
Okay? And you also have the option of encrypting your EBS volumes at rest for the data at rest.
Normal na sa akin, lalo na pag nanigo ako na malamig.
So that's one way of doing it. Another way is by creating EBS volumes directly as an independent resource. So let me transition back to North Virginia and let me create an independent EBS volume, specifying the same things. AZ placement is important because you can only attach EBS volumes on EC2 instances within the same availability zone. Okay? If you do have snapshots, then you could use those snapshots to restore your EBS volumes. You can also have encryption at rest. Okay, so let me just name this as ABS CVN volume. So as mentioned, that once this volume has been created, even though you have not attached or used this, you'll start incurring charges for this EBS volume. Okay? But once we have a running volume, let's say this one, we can then attach this to a corresponding EC2 instance. If we do have any instance that we can attach it with. There we go. We can attach this. But we need to still go into our instance, mount the volume, and format the device. Well, later on, we also have the option of detaching this instance. So let's just wait for this instance. Let's just wait for this volume to be attached. Okay. And we also have the option of detaching this volume and then reattaching it to a different EC2 instance. You can also create snapshots of your volumes.
Sige, ito muna sa
Let me just do that. You can create a snapshot. And once you have created a snapshot, you can then use these to recreate or restore your EBS volumes.
Ito.
Okay? So essentially, it really is like a disk drive, and you use it the same way of how you use your disk drive. This is where you'll be installing your operating system
Palaman.
and applications that you want to be running on your EC2 instances. And so that will be it for my demo on EBS. We have captured everything that we've discussed in this module for EBS. Next, let's move on to Amazon S3 or Simple Storage Service. So Amazon S3 is our object storage in the cloud. And there are some key differences between block devices and object storage. First of which, object storage allows you to store and retrieve files from the internet. Right? Secondly, the data in object storage are immutable. The files are immutable. In other words, if you want to update the contents of the files, then you would need to upload the whole file altogether to overwrite the previous version of your file. So, because of that nature, object storage is designed for storing relatively static data. And that is consistent with Amazon S3, a service specifically designed for static content. So this is where you can offload things like your web pages, your index, your HTML, your CSS, JavaScript, images, videos, thumbnails, and so on out of your EC2 instances. So that your EC2 instances can focus on serving application logic, and your front-end web page can be served by your Amazon S3. And through those characteristics, you can think of Amazon S3 like familiar services that you've probably been able to use. Services like Dropbox, okay? Or more commonly from our competitors, that would be Google Drive, right? Which is much more, used among Filipinos, right? Google Drive.
Haba na Google.
But in addition to that, Amazon S3 does provide you with APIs so that your application code can programmatically interact with Amazon S3. So with Amazon S3, you can store any amounts of objects. It virtually provides you with unlimited storage space, given that each file does not exceed 5 terabytes. But you can upload any amounts of files, as long as each file is not over 5 terabytes. S3 is designed for 11 nines of durability. In layman's term, it simply means that for every 10,000 files that you have in S3, only one file might be lost or corrupted in 10 million years. And how we achieve that level of durability is because S3 is a regional service. The data that you store in S3 is automatically replicated across multiple availability zones within the region. Furthermore, Amazon S3 is designed for high availability, where unplanned downtime is very minimal throughout the year. For security, since you are interacting with S3 over the internet, you do have the option of establishing secure connection with SSL endpoints so that you can encrypt data in transit. And since this is a storage service, you also have the option of encrypting your data at rest. And for auditing purposes, we do provide you with access logs for you to be able to monitor how your S3 is being used and accessed. Some concepts that you need to be mindful of is that within the S3, you need to create buckets. And in buckets, you can think of this as folders, but more specifically, these are the root domains, where you can store objects, or in this case, these are simply the files that you want to store in S3. They're class objects. Now, do note that for S3, you can upload as many objects as you want, but you need to ensure that each object does not exceed 5 terabytes. And you can store any objects that you want. You can store Word docs, you can store PDFs, Excel sheets, images, videos, GIF files, MP4s,
Wala
MP3s,
nung
and
mga
so on. Anything, as
subscriber
long
ng
as it does
ABS.
not exceed 5 terabytes.
Hindi talaga.
Now, each object that you upload in S3 will be given a unique URL, where the bucket name is used as the domain name, and the object or key name is used as the path for that domain.
Yan.
Important thing to note here is that since your bucket name is used as the domain name for this URL, you must ensure that your bucket name is DNS compliant
Understood na yun. Ang
and
tagal
also
na.
globally unique.
Proven naman, ano.
But even though objects are given
Proven na
unique
yan.
URLs, it doesn't necessarily mean that anyone can publicly access
Kaya
your
kumain para
objects.
kasabay natin.
You have to decide on that. Because we give you mechanisms to control access and permissions to the bucket and the objects within your bucket. And these are controlled via ACLs, bucket policies, and AWS IAM. For added security, you can also encrypt your data in transit with SSL endpoints, and you also have the option of encrypting your data at rest. But all of these features are merely available, but you'd still need to explicitly enable and configure them when deemed necessary. One of the features of S3 is versioning. And versioning allows you to store not only the up-to-date version of your data, but also older versions of your data. And this gives you the opportunity to roll back to a previous version that can protect you from accidental deletes and accidental overwrites. Because again, because you are storing the previous versions of your data, you'll be able to roll back to that previous version. Right? But do note that one of the pricing factors of S3 is storage consumption. Storage fee, essentially. And because not only are you storing the most up-to-date version of your object, but you're also storing the previous versions of your objects, added charges may be incurred. Because all of these entities, the most up-to-date and the previous versions, are all consuming storage space. But this feature does help you in protecting from accidental deletes and accidental overwrites.
Ako lang yung groovy.
Another feature of S3 is object lifecycle. And in order for us to appreciate this feature, we need to understand that within S3, we do have various storage classes. Now, these storage classes are designed for you to efficiently store data. This can also be a cost optimization mechanism whereby you'll be able to save on cost depending on the object access path. So let's discuss these classes. The default class would be the Amazon S3 standard. And this is designed for your frequently accessed data. Amazon S3 standard is designed for 11 nines of durability and high availability. And again, this is specifically used for your frequently accessed data, and this is also the default storage class. But the data that you be storing in S3 will not be always frequently accessed. There might be some data that you store in S3 that will be infrequently accessed. And typically, data that is accessed less than once a month is determined to be infrequently accessed. And so for those types of data, you have the S3 standard IA or the standard infrequent access. The standard IA is still designed for 11 nines of durability. It's also designed for high availability. It's very similar to S3 standard in a sense that you also have immediate access to the data when requested upon, with the added benefit that the storage fee is way lower in comparison to S3. But the caveat here is that the retrieval fee is a little higher in comparison to S3 standard. But do not be intimidated by this increased retrieval fee, because it is assumed that the data that you'll be storing in this class will be infrequently accessed. Therefore, it is less likely that you'll be incurring this retrieval fee, and so you'll be able to still save on cost because of this lower storage fee. Again, this is specifically designed for your infrequently accessed data. But what if for your infrequently accessed data, you want to further save on cost? Because you deemed that you do not need this level of durability. It's too much. For those non-critical, infrequently accessed data, you have the S3 one zone IA. And as the name suggests, one zone IA, in contrast to the previous two classes, this will only be replicating your data in one availability zone within the region. And that theoretically means that the durability is lower and also the availability. But the benefit here is that the storage fee is way lower, but the retrieval fee remains the same. So S3 One Zone IA is designed for your infrequently accessed data that you do not need or that is non-critical. Essentially, it is not requiring you to have that amount of durability. Now, for your archival data, as a replacement for your virtual tape libraries, you have the Glacier and Glacier Deep Archive class, both of which are designed for archival or backup data. Okay? Both of these are very similar. Both are designed for 11 nines of durability. Both are also designed for high availability once the item has been restored from the archive. Both offer relatively cheapest storage fee, where Amazon Glacier Deep Dive, or rather Glacier Deep Archive, is substantially much more cheaper than S3 Glacier. But the caveat of these two classes is that these are for your archival data. And the caveat here is that restoring items from these archival classes can take a while. Because the idea here is that we put your data in a glacier, we freeze them, we put them in ice. And so when you request for the data, we need some time to thaw the data. And the thawing process for Glacier can take between 1 to 12 hours, 1 minute to 12 hours. For Deep Archive, restoring data from the archive can take between 12 to 48 hours. So with that, this is essentially designed for your archival data. So now that we have learned about different classes, you might be worrying that along with this, you have a lot of objects that you need to store and manage in S3, making it very difficult and complex to understand, which class is suitable to store my data in. It's also very hard to move between these classes, especially if you have millions of objects being stored in S3. Now, to assist you in managing these objects and their classes, we do have the automated way of doing it with S3 Intelligent Querying. S3 Intelligent Querying leverages on a machine learning model that we have created for you that will analyze historical data patterns of your objects and will be able to automatically decide which class it is most suitable to store the data. And it automatically moves the object on your behalf as well. So S3 Intelligent Querying is very handy, especially giving you the convenience of not needing to manage each object and how to move between these classes. Do note that data stored in Intelligent Querying, depending on which class they are stored in, will still follow the class pricing, but we do add a very minimal fee for the automation of object management. Okay? Alternatively, another way to automate the movement between these classes is by defining object lifecycle rules. Object lifecycle allows you to define rules that would describe how you want to move objects between classes based on their age. So to give you an idea of what rules you can define, let's say, for example, initially you store your objects in S3 standard. But after 30 days, you expect that the data will be less frequently accessed. And so you decide that after 30 days, you will define a rule that will automatically move the object from standard into standard IA. And this rule is something that you need to define. Well, let's say after 1 year, you want to store this as an archive. And so you need to create an additional rule that after 1 year, move it into S3 Glacier. So you store it in Glacier until you have reached your data retention period requirements. Once you have achieved that, let's say for 2 years, then you have the option of completely deleting the data. So in here, we see the possibility that we can do with object lifecycle. Essentially, it allows you to describe a set of rules that will automatically move objects between classes based on their age.
Grabe yung ako, ano?
Okay? So the common use cases
Ah,
of S3 is that you could use this as your storage and
grabe.
backup solution. You can also use S3 to host your application files and your media and also deliver softwares. And this is also the service that is used to store your AMIs and snapshots. In terms of pricing, S3's price is mainly driven by storage fee, your storage consumption. But all the requests that you send to S3, all the HTTP requests and API calls that you invoke will also incur charges. Data transfer will also be incurred. And generally speaking, data transfer in of S3 is free of charge. But data transfer out will incur charges. And if you're using management, analytics, and replication features of S3s, these might also incur extra charges. Okay, we've already discussed that. And essentially, that will conclude our discussion on S3. So before we cap this module off, let me just quickly show you a demo on S3. Okay, so first and foremost, you would need to create a bucket. And as mentioned, the bucket name must be DNS compliant and globally unique. Okay, so let me create a ABS CBN bucket. Hopefully this is globally unique. I will be selecting the region as to where I want to create my S3 bucket. And I also want to be enabling versioning. And that would be it. So let me create this bucket.
Kasi ito, hindi naman to applicable sa atin eh.
Okay. So I have successfully created the ABS CBN bucket. And remember that this will be used as the domain. And since when you are defining bucket names, it must be globally unique. So if you want to use this bucket name, then feel free to reach out to me via emails and let's discuss how you are going to be paying for this domain name. Okay, I'm accepting Gcash payments or bank transfer payments. All right, obviously I'm kidding. I'm going to delete this bucket after this session if you want to use this bucket name. Okay. And so with that, you could use this like any object storage. Now, if you've used Dropbox, then the interface might be familiar to you. Okay? But essentially, you can upload any files that you want, any amount of files as well, as long as each file does not exceed 5 terabytes. Okay? So let me upload an image. Right? Now, in this image, up front, I am able to control its permission, whether or not I want this to be open to everyone or be a private object. For properties, I can define which class I want to store this image in. We've discussed everything of this. And if you just want to automate the process of, managing the object class for you, then you can decide to put it in the intelligent tiering. But for now, I just want to place it in the default class, which would be the standard class. Okay, I can have encryption at rest for this object, but for now, that would do. All right, and so this image stored in S3, we are now able to store and retrieve this over the internet. So let me open up this image, and it will show me. And possibly this is how you are right now, with the amounts of information that I'm giving you. All right? And so that is S3. And remember that we did have versioning enabled. So let's say, for example, let's overwrite the file. Let's just say we have edited the image and we have overwritten the file accidentally. Because again, editing objects in S3, you need to upload the whole file altogether in order to overwrite the older version of your file. So let's upload the same image, and that would simulate the process that we have accidentally overwritten our image. And so if we want to be able to roll back to a previous version, then we do have the option of showing the versions, and we can delete the most up-to-date version so that we can roll back to the previous version. So we have rolled back. And let's say, for example, we have accidentally deleted this object. So for now, we're unable to see it. But in actuality, if we show the versions, the object is still there. We simply place a delete marker placeholder. That would suggest that the object has been deleted. But since we are storing the object, even though we have quote unquote deleted it, it's still consuming storage space, which means that we are still paying for this object. And so if we want to retrieve a accidentally deleted object, then we simply need to delete the delete marker. There we go, the object is back. And if you want to completely delete the object, as in delete it completely, then you would need to delete the version itself. Okay, so that is S3. Another thing that is noteworthy would be the management, because again, you can define lifecycle rules, which is a definition of how you want to automatically move objects between classes based on their age. So let me get this a lifecycle rule. And I can limit the scope of these rules on specific objects, subset of objects, or I can apply this rule to all the objects in the bucket. And now I can define the transition rules. And let's say I want to apply this rule to the current versions of my objects, whereby after 30 days of creation, I want it to be initially transitioned into the standard IA. And then I can add another rule that will move it into Glacier after 1 year. Okay? I can also define rules that will permanently delete these objects once we have reached these hallmarks. Alright? And so I can expire a current version of my objects, and I can define the rules to say that after, let's say, 2 years, I want the objects to be automatically deleted. And here we see a snapshot of the object lifecycle rules. What will happen if we create this rule? Where initially, it will be stored in S3 standard, but after 30 days upon uploading the object, it will be transitioned to standard IA. And again, after 1 year upon the object creation, it will be transitioned onto Glacier. And after 2 years, the objects will be completely expired or deleted. And so with that, that will help us then automatically manage our objects within S3. And that will also conclude my demo on Amazon S3. Hopefully that has reinforced our understanding on S3. So in summary for this module, we have differentiated 3 storage services: EBS, S3, and instant storage. Now, I'm not going to go through this table of comparison because we have discussed everything in this section. But to give you an analogy, Amazon EBS should be treated like a disk drive that you mount onto your EC2 instance, whereas Amazon S3 must be treated like object storage. And this object storage allows you to store and retrieve files over the internet, which means that they are not mounted onto EC2 instances. Rather, you interact with them using the S3 APIs. And lastly, we had the instant storage. And instant storage must be treated like a volatile memory, giving you really fast read and write performances, where persistence isn't its main suit. It's only an ephemeral or temporary storage. And with that, that effectively concludes our discussion for this module, or rather this section on storage services. Again, in summary, we've differentiated these 3 storage services, namely instance storage, EBS, and Amazon S3. So before we move on to our next module,
Saan ko nga?
are there any questions with this section of
Saan ko yung
discussion?
itong ABS
Any
hardware?
questions or is everything good so far? Is as in S3, we have a question from Bonby. In S3, is object automatically copied from one region to another? Great question, Bonby. And the answer is no. And the reason behind that is because some organizations need to comply with data residency laws or data sovereignty laws that will enforce them to keep their data in that same country. And they are unable to replicate it to any other countries. And because of that regulation, S3 by default is designed to keep the data in the same region by default. But we do enable you to replicate your data in a different region if necessary. But this is something that you would need to configure and explicitly enable. And so for that, for S3, we can go to management as well, and we can define replication rules. And as you can see, by default, the data in S3 is not replicated to any other regions, but you can create a replication rule that will replicate your data in this bucket into a different region. You have that feature, but it's not enabled by default. So hopefully that answers your question, Bonby. From Albert, is there a way to see who's currently using the S3 bucket and view the progress of each transfers in real time? The answer is no. There's no way for you to see that. Okay? There's no way for you to see the connections that are currently being done and the transactions that are being done on S3. No visibility on that. Okay? But what you do have is access logs. Okay? But it will be reflected after the transaction is made, not during the transaction. Okay? So any more questions with regards to storage services before we transition on to our next module? Any more questions or is everything clear so far? All right. So it seems that everything is good with this module. And so let us transition on to our next module. And our next module deals with security, identity, and access management, which is very crucial in any IT environment. So in this module, we are looking to discuss the shared responsibility model and describe our responsibility as part of that shared responsibility model. We'll also be diving deep into the capabilities and the components in AWS IAM service or identity and access management. Okay? But first of all, we are going to be quickly touching upon the shared responsibility model. And this is something that we've already discussed in our morning session, whereby in order to maintain cloud security, we must be understood that both stakeholders, AWS as the cloud provider, and you as the customer, we have our own distinct set of responsibilities in maintaining cloud security. AWS is responsible for the security of the cloud, whereas you as the customer, you are responsible for the security in the cloud. Now, security of the cloud pertains to the infrastructure that is running our services. So we will ensure that the infrastructure, data center, and the hardware resources are secure and reliable for use. On top of that, we provide you with features that you could use to increase your cloud security, It is also our responsibility to be compliant in our data center operations and retrieve certifications and also generate reports, documents, and white papers to educate you on how to be compliant in the cloud. So, to put it simply, anything below the hypervisor level is our responsibility. For the most part, if it deals with hardware, it is our responsibility. Now, let's look at your responsibility in maintaining security in the cloud. Generally speaking, security in the cloud pertains to everything above the hypervisor level, which means that you are responsible for the data and the applications that you host in the cloud. For EC2 instances, for example, you are responsible in updating or patching the operating system, installing and updating the runtime environments, and so on. For storage services like S3, you are responsible in enabling the features that we provide you with. For example, having encryption at rest and in transit is available, but it is something that you need to explicitly enable when necessary. Right? That includes replication into a different region. Features are available, but you need to explicitly use them and configure them. On top of that, access and permission to these resources are also your responsibility to control. Okay? So looking at our set of responsibilities, AWS would be handling the physical security. Essentially, our data centers are located in undisclosed locations that even I myself, as an AWS employee, I do not know where our data centers reside. On top of that, our data centers are well staffed and well surveillance, and you would need to go through a rigorous authorization process for you to be able to enter our data centers. We also have hardware, software, and network security in place in our data center operations. On top of that, we do provide you with features and services that you can leverage on to increase cloud security. These features would include SSL endpoints for encryption in transit, firewalls in multiple layers with security groups and network ACLs, as well as Amazon VPC, providing you with a private, isolated, and secure network space in the AWS cloud. Okay? And one of the services that we'll be focusing on this module would be all about AWS IAM, or Identity and Access Management. In a gist, this is a service that will allow you to centrally manage authentication and authorization. Authentication deals with identity, and this answers who you are. Authorization deals with permission, and that answers what you can and cannot do. So, if we put this in an analogy, you can think of AWS IAM as your cloud native Active Directory. And actually, the concept within IAM is very similar to Active Directory. So if you were a system admin, our discussion on IAM would be very familiar if you are dealing with Active Directory. But do know that IAM is not a replacement for Active Directory. Instead, we even provide you with integration that you can use IAM to supplement your Active Directory. Because essentially, IAM is your cloud native access and permission control. And so the components in IAM would include users, groups, roles, and policies. So let's discuss each of these components, starting with the authentication aspect of IAM. Again, authentication deals with identity that answers who you are. And one of the components in IAM that provides you with that identity would be an IAM user. So an IAM user is able to provide identity through static credentials. But an IAM user is not limited to providing identity to a person. It may also be used to provide identity to your device that you use to interact with AWS. It can also be used to provide identity to your application code or even AWS services. Okay? In general, it does provide you with identity through static credentials. And with IAM users, you have multiple different types of static credentials. each one providing you different levels of access. One type of static credentials would be the username and password. And you could use this to log in into the AWS Management Console. Another type of static credentials would be the access key credentials. And you could use these to authenticate your programmatic calls through the AWS command line interface or the software development kit. Okay? Now, do note that a user is a separate entity from an AWS account, but a user is a part of an AWS account, which means that in an account, you can create multiple users. And so it's very crucial to be able to organize and manage multiple users in an account. How we help that is with IAM groups. So IAM groups' sole purpose is to organize and manage users in an account. Furthermore, by having groups, it alleviates the need for you to individually assign permissions to each and every users. So instead of assigning policies to each and every users, you can then assign policies to the group, and all of the users that you add to that group will inherit the policies that you have associated with that group. Okay? And speaking of assigning permissions, for the authorization aspect of IAM that deals with what you can and cannot do, these are dealt with IAM policies. IAM policies are JSON documents that describes the permissions of what you can and cannot do in the cloud environment. And these policies can be assigned to users, groups, or to roles. So we hear a sample IAM policy. Again, this will be written in JSON, and this policy describes what actions you want to allow or deny, what resources will be affected by this policy, and what optional conditions must be met in order for you to allow the transaction. Okay? So essentially, once you have defined that document, that will be packaged as an IAM policy, which then can be assigned to a user, group, and a role. So far, the components that we've discussed are user groups and roles, and these are easy concepts. The last component is also the most complex and the most tricky to understand, and that would be IAM roles. So IAM roles is very similar to IAM users. Okay? Wherein this is the component that will also grant identity. But the key word here is that it is able to grant that credentials and permissions in a temporary manner. There is an expiration period. Furthermore, IAM roles does not have any credentials, unlike users. Because IAM roles are something that you need to assume in order to be granted that temporary credentials and permissions. So to put it simply, think of it this way. In your computer, there are some applications that you would need to be running as administrator. And you would have administrator permissions while you are running that application. But you only have that permission in that application. And once you exit the application, you have now sacrificed or you have now put down your admin permissions. And IAM roles is similar to that. Not necessarily granting you admin permissions because you can define what policies that you associate to IAM roles, but essentially this gives you that temporary credentials and permissions that will allow you to carry out a task that might not be possible with your original set of credentials and permissions. And so IAM roles do play a huge part in the AWS cloud. Okay? Because this is something that is assumed by your users or even your AWS resources. One of the use case of these roles is to enable service-to-service communication. For example, you have an application hosted on an EC2 instance that would need to interact with Amazon S3. This interaction between these services, you would need to have the necessary credentials and permissions to do so. Specifically, your application would need to have the set of credentials and permissions. So one way you can grant these set of credentials and permissions is by embedding static credentials on your EC2 instance or embedding it in your application code. These static credentials are your access key credentials that is given to your users. So you can actually embed these static key credentials in your application code or store it in your EC2 instance. Okay? Now, although that is a viable option, this is not the recommended way of providing your application the necessary permissions and credentials to interact with another AWS service. And the reason behind that is because if you are embedding static credentials, and if you share this code via a repository, for example, then anyone who has visibility on those set of credentials will be able to use it on your behalf. Again, although viable, it's not the ideal way of granting credentials and permissions. So instead of doing that, consider using IAM roles. Because IAM roles is something that it doesn't have static credentials. It is something that you assume or distribute. And it's a much more secure way of enabling service-to-service communication. How this works is, let's say, for example, you want to allow the application hosted on your EC2 instance to be able to interact with S3. Upon the launch of your EC2 instance, one of the details that you could have defined would be the IAM role. And so you can assign your instance with an IAM role. And this IAM role should have the necessary permissions to access the S3 service. Okay? So whatever roles that you have assigned on your EC2 instance, that will be inherited by the applications that is hosted in that instance. And so this app will inherit the permissions of this role, which will grant this application the necessary credentials and permissions to interact with Amazon S3. Okay? Now, another use case of these roles is that it can also enable temporary change of permissions within the account. Really, it's a multi-purpose entity in IAM. So let's say, for example, you have a user that has a restricted policy that will deny this user access to S3. Well, let's say this user temporarily needs access to that S3 bucket. How can we facilitate that? Well, one option that this person has is that he or she can request to the system admin to change his or her own permission. Hold on, let me just answer a call. Right. Sorry, that was emergency. Sorry for the interruption, but going back to our slides. All right. So again, one option that this person has is to request from the system admin to change his or her permission for this user. System admin does that. User now has access to S3, and once this user is done with the task at hand, it then again communicates with the system admin to revert back to its original set of permissions. Again, although possible, there is a lot of overhead unnecessarily being introduced. And so instead of doing that, we create roles in the account. And this role should have the necessary permissions to grant access to this S3 bucket. What this user can do is to assume that role, and this user will effectively drop its original set of permissions, and it will assume the permissions associated with the role. And so while it is assuming that role, it now has the permissions to access the S3 bucket. But do remember that roles is merely a temporary way of granting credentials and permissions. So after the expiration period has been met or it has dropped the role, then this user will revert back to its original set of credentials, which again will deny access to this S3 bucket. Okay? Another use case of roles is that it can facilitate cross-account access. So let's say, for example, you have a manager who has his or her own account. And this manager will need to oversee multiple accounts as part of the project team. Instead of creating service users and sharing static credentials to your managers, which again is possible, it's not the most cloud native way. Instead, you want to create roles instead. So your manager having his or her own account will be able to assume that role, which will effectively drop this user's original set of permissions and grant permissions to access account A, facilitating cross-account access, eliminating the need for you to create service users. Okay? So when you are assuming this role, IAM roles is actually integrating or interacting with AWS SDS or secure token service to generate those temporary security credentials. And these
Load mo na ako,
credentials can
nakakita.
only be valid
12,000
between
na chat na
15
ako
minutes
sa'yo.
to 36 hours.
Meron.
With this does facilitate a
Basahin mo
lot
kasi.
of workloads that deals with temporary access and permissions. Now do note that IAM is only able to control permissions below not beyond the hypervisor level. Essentially, it's only able to control API level actions. In other words, IAM is only able to control whether or not the user can create or terminate EC2 instances. But it's unable to control whether or not a user can SSH or RDP into the instance,
Screens lang
or
ba?
it cannot also control whether or not applications must not be allowed to be installed on that instance. If you do require control beyond the hypervisor level, then do consider using third-party services or applications like the Active Directory, who is capable of doing so. Okay?
Meron yan.
So in summary, IAM is a service that allows you to essentially deal with authentication and authorization. Authentication is answering the identity that answers who you are, and that is dealt with user, groups, and roles. Authorization answers permissions that controls what you can and cannot do, and that is dealt with IAM policies. Okay. Now, let's just go through quickly some of the best practices in relation to IAM. And one of the first users you have access once you create a new account would be the root user. And the root user has inherent admin permissions, and you won't be able to control the permissions of the root user. And because of that, you do not want to do not want to use the root user for your day-to-day tasks. Instead, what you want to do is to create an IAM user using that root user that has admin permission. Now that may seem redundant, but do know that IAM users you are able to control permissions, whereas for root users you cannot. And so you want to leverage on that IAM user to perform your day-to-day tasks, and you want to use that to create subsequent users if necessary. For new users, when granting permissions, do note that you want to grant least privilege. You want to follow the principle of least privilege. Essentially, this is describing the act that you only want to provide the permissions that is necessary to carry out the task, nothing more, nothing less. And you want to create customer managed policies instead of inline policies for reusability. Use access levels to review IAM permissions and configure a strong password policy, and optionally enable multi-factor authentication for your privileged users, like your admin users. Use roles for applications that run on Amazon EC2 instances instead of embedding static credentials. And also to facilitate cross-account access, you want to use roles instead of creating service users. If you do have users, you want to be able to rotate credentials regularly. Furthermore, you want to activity in your AWS account. Essentially, you want to be able to track all the actions that were made in your account. And how you'll be able to monitor activity in your account is through a service called AWS CloudTrail. AWS CloudTrail is your audit trail service, whose main purpose is to record all of the attempted API calls that were made in your account, giving you a backlog of all the actions that were performed in your account. Okay? And so with that, that effectively concludes our discussion for this module. So in this module, we have described the shared responsibility model, and we've also understood our distinct responsibilities in maintaining cloud security. Furthermore, we've deep dived into the capabilities of IAM, allowing us to manage authentication and authorization in our cloud environment with users, groups, roles, and policies. We've also briefly looked into AWS CloudTrail, our auditing trail service that can record all of the attempted API calls that were made in our account. So before we take another short break, possibly just 5 minutes before we move on with our next module, are there any questions with this module on security and IAM, or is everything good so far? All right. I am receiving substantially fewer confirmations, so it's either you are all good or you are completely lost at this point. So hopefully it's the former one. All right. Hopefully everyone is still with me. And with that, I think we should be able to take a short break, a 5-minute break. So let me pull up a timer for 5 minutes.